Hey, so I had some difficulties recording 7.1, but you know what? This is what it is. I didn't want to start over, so I just left what I had before the phone died or whatever, but now it should be fine, so let's find out. So what I wanted to tell you about 7.1 is that, or all of chapter 7, is that we're dealing with fractions. And fractions, these are the things that we had to remember the rules for fractions when we're just numbers. But now we're going to do all these things, but with polynomials, things with letters. So that means it's not going to be quite the same. It's going to be very similar, but there will be something specific for polynomials. Like, for instance, reduce is what 7.1 is all about. Now, when we reduced fractions in the past, like 3 over 15, we would divide both top and bottom by 3, right? And that would give us 1 over 5. But here, for polynomials, we have to do this instead. And that means we have to factor both the top and bottom separately, like we did here. GCF was 5, so I divided by 5, and I got this. And then for here, I factor out a negative 1. Now, the reason why is because what happens is it changes the signs, and then you have the same thing. So before, the signs weren't right. 9 was negative, but here 9 is positive. 7x is positive, but here 7x is negative. So when I factor out a negative 1, it changes the signs, and now I can rearrange them so that they're the exact same thing, and they cancel. So you only can cancel things that are the exact same after you factor. That's the rule. So really what all you're left with here is 5 over negative 1, which is just negative 5. Okay? So this is more about what we're doing in 7.1. We're just going to factor and cancel, essentially. So it's a bunch more factoring problems. 21x minus 27 over 9x minus 7x squared. So when we factor the top here, we have, what do they have in common? 3. Yeah. So when we divide by 3, we're left with 7x minus 9. All right. And then down here, what do they have in common? Well, not a number. They have a letter in common, x. But not only that, once again, the 9 is positive where it should be negative, and the 7 is negative where it should be positive. So let's pull out a negative 1 times x, or a negative x. And what that will do is that'll change this to negative 9 when we divide by negative x and positive 7x. And now they'll cancel, and we'll be left with negative 3 over x, or 3 over negative x, same thing. So be careful. Whenever you see the same terms, but they're in the wrong order with a minus sign, all you have to do is factor out a negative 1. And it should fix it for you. Okay. Number 3, x plus 7. And that's over x squared plus 5x minus 14. Now that I'm good at factoring, I can see that this is a trinomial. This doesn't factor at all, so it's still just x plus 7 up here. And this is a trinomial where we factor by going, what two numbers multiply to give me 14, but subtract to give me 5? And that's 7 and negative 2. So we end up getting x plus 7, x minus 2. And if you have to go off to the side to do a little x thing, please go do that. That's great. So now that we factor, we can cancel these x plus 7s. And that leaves x minus 2 in the denominator. But what is in the numerator? Invisible 1. Okay? Number 4, we have x minus 10 over x squared minus 100. And this one's on here to throw you off because there's something very important you must know. And that is you cannot break off a piece of one of these polynomials and cancel with what's down here. So like you see that 100 and 10 are in common. And in the past, if this was what we started off with, we would reduce this. 10 would go into both and we'd be left with 1 over 10. Don't do that. That's bad. So 10 is connected to this x with this minus sign, like glue. And so if you're going to do something like divide by 10, you got to divide 10 out of him, and he doesn't have a 10. So you're not allowed to do that. What you are allowed to do is factor. And on the top, there's nothing to factor. It's just x minus 10. But in the bottom, this is the difference of two squares. So you're left with x plus 10 and x minus 10. You know, that whole plus minus thing. And oh, look, the x minus 10s cancel now. They're exactly the same. So that leaves me with 1 up here and x plus 10 down here. right? All right, so just don't fall in that trap of seeing two numbers that have something in common and go, ooh, ooh, ooh. That would be bad. All right. 2 minus x. Okay, so I don't know what's going on with that yet, but let's just deal with the top. X squared minus 4, that's that whole plus minus thing again. X plus 2, x minus 2. And then down here, I would love it for be x minus 2, but the signs are wrong. So once again, if you remember, factor out a -1, and you'll be left with -2 plus x. Now the signs are correct, and they can cancel. And that leaves x plus 2 divided by -1. Now, if you divide a single number into a binomial, it can go into both of them. So this becomes -x minus 2. Or you can leave it -1 out front and x plus 2 in parentheses. I figured that would be fine too. Let's see what they said in the answers. Number 5, yep, this. All right. Number 6. Can you guys see it? Yeah. Okay. So we have 3x plus 2 in the top. Nothing to do with that guy. So I'm going to put him in parentheses and leave him alone. In the bottom, I have 12x squared plus 17x plus 6. And this guy is 3 terms, and I would really like to factor him with some other easier method, but I don't have one. I'm going to have to do the snowflake. Yep, that's just how it goes. It'd be like that. 12 times 6 is 72. That's what goes in the bottom. The middle number goes in the top. Then I go, what two numbers multiply to give me 72 and add to give me 17? It's 9 and 8. Okay. Put 12 above both of them and then reduce. This guy reduces by dividing by 3 to get 4 over 3. This guy reduces by dividing by 4, and we're left with 3 over 2. So what these two give me is 4x plus 3 and 3x plus 2. Oh, man, that's nice because there's already a 3x plus 2 up here to cancel with. Boom, boom. So 1 over 4x plus 3 ends up being the answer. So it's all about factoring and canceling. Okay? Number 7. We have 2x squared minus 16x plus 32. And that is over x minus 4. So this is kind of reverse what we've been doing. This guy has nothing to do. So he's just going to come straight over. But this guy, they all have a GCF, don't they? So you can factor out a 2 first. And that'll leave you with x squared minus 8x plus 16. Now, still nothing cancels. But this trinomial factors as well. So it factors, it's the difference. Actually, it's a perfect square trinomial. Look, x and 16, they're perfect squares. This would be x, and this would be 4, and that would be half the middle. So x minus 4 squared, or just x minus 4 times x minus 4. And I'm writing it like that because one of them is going to cancel, not both. Right? So if you factor this, you should end up getting something like this, or this squared, and one of them cancels. So the answer is just 2 times x minus 4, no denominator, or a 1 denominator, which we don't want to write. Yay, no fractions. So don't think of this as a fraction problem. Think of it more of as just factoring problem. And we've been doing that, right? We've just been doing factoring for the whole of chapter 6, and that was week 1 and week 2. Now week 3, we're doing factoring some more. Just a little factoring. All right, so we're going to factor both the top and the bottom in this one because x squared minus 25 becomes x plus 5 and x minus 5. It's difference of squares, right? The plus minus thing. And then this one, you have to think of what two numbers multiply to give you 15 and add to give you 8. That's 5 and 3. Like so. And oh, look, x plus 5s. Boom. That leaves you with x minus 5 up top and x plus 3 in the bottom. Yeah, you could put the parentheses on there if you want to, but if it's just the one term, I don't. And now this is one of those things that you see those x's and you're like, oh, I want to cancel them. Don't do it. Don't be that student. You're better than that. Okay. X cubed minus x squared plus 3x minus 3. And that's all over x minus 1. So in this case, I've got a 4-term thing, and if you remember that, the only thing that factors with 4 terms is grouping. So I might have to go off to the side and kind of do this. X cubed minus x squared, and then 3x minus 3. And then we got x squared as a GCF, and you're left with x minus 1 when you divide. 3 is a GCF, and you're left with x minus 1 when you divide. So the first one is going to be x minus 1, because they're the same thing. And then the leftovers, x squared plus 3, end up being in a parentheses together. And the bottom stayed the same. Now the x minus 1's cancel. And your answer is x squared plus 3. So factor by grouping is the only one where I have to go off to the side and do some stuff. That and snowflake, right? And it's just how it is. It'd be like that. Number 10. 3x minus 6 over x squared minus 7x plus 10. All right, GCF for the top. They both factor. This guy has a 3, and then if you divide by 3, you get x minus 2. This guy, you have to think of what two numbers multiply to give you 10, but add to give you negative 7, and that's negative 5 and negative 2. And oh look, x minus 2's cancel. So you're left with 3 over x minus 5. Okay, that's 7.1 for you.